Welcome again, Algebra Scholars. This is part 2 of Lesson 3.6 on compound inequalities. And no, that's not a typo at the top of the page. That's a pun. We called it More 3.6, Compounding Inequities. So what we're going to do on this page is practice what we've learned in part 1. So we learned how to combine two different inequalities using the word and how to combine them using the word or. So basically that's what we have on this page, a bunch of inequalities that are combined with the word and combined with the word or. So in number 1 we see two inequalities combined with the word or. So what we need to do is we need to solve each of these separately so we know what we're going to try to draw the graph of. So as I solve this first one, I'm going to want to get the m by itself. So I need to get rid of the 4 and the minus 5. I think the best place to start would be adding 5. That will give us 4m greater than 12. Now to get rid of the to get rid of the 4 and get the m by itself, I need to divide by 4. That will give me m greater than 3. For the other part of this inequality, it starts with the same expression, 4m minus 5. So I can do the same two steps. I can add 5 on each side of the inequality. That gives me 4m is less than negative 4. And then I can divide each side by 4 and get m is less than negative 1. Now let's remember to put the word or in there in between those two. So now when you look at the right-hand side of the page here, you're going to see that there's only one number line. In the previous activity, we used 3 number lines for every problem. Why is there only one? Well, technically, you really only need one. You just have to draw 3 graphs to get to the answer. So as we draw the graphs, let's draw the scratch work graphs higher and draw the final answer the closest to the number line. So when I graph m greater than 3, I'm going to need an open circle above 3. So I'm going to come really high on the page here and put an open circle on negative 3 and then shade to the right. For m less than negative 1, I'm going to need an open circle above negative 1. So I'm coming a little lower than the first graph. Kind of like we did on the other page. We had a top number line, a middle number line, and then the answer one on the bottom number line. So m less than negative 1 would be an open circle on negative 1, shading to the left. And now I want to put these together with the word or. So when I combine with or, I just put the union of the two sets. I put it all in together. So I'm changing colors here just to be clear that this is the answer now. I'm going to put in all of this because all of these numbers work. They meet requirement, the second requirement, m less than negative 1. And I'm going to color in all of these numbers because they meet the first requirement. I don't have to leave anything out. That is my solution set. So the simplest way to write that solution set is to just describe what you see on the graph. The first thing I see is, now I'm going to use the letter m here, I see that m can be less than negative 1 or m can be greater than 3. That's very close to what I had written over here on the left in green. I just have them backwards in green. I'm reading from left to right on the graph, so I have them in a different order. So now you get to name 3 numbers that are in that solution set. This is basically just to strengthen your understanding of what it means for that to be the solution set. Any number that's colored in dark that doesn't have an open circle on it, that's a solution. So I can pick a number like, let me make a set symbol, like negative 5. That line going across above the negative 5 means negative 5 is colored in. I can't include negative 1. I could include negative 2. Negative 2 has a dark line above it, or even positive 5. Now I've chosen only nice numbers. I could choose fractions, decimals, anything. So really, it's hard to be wrong on that unless you include numbers in between negative 1 and 3. If you included 0 or 1 or 2, for example, you would be incorrect. Those numbers are not colored in on either line, so they're not in the solution set. Let's move on to number 2. Number 2 looks a lot different. Sometimes people get really confused about this problem. I want to do this problem for you in 2 different ways. The first way is how I would do it, and then I want to do it a second way just to see if it'll make more sense to some people if this first way really doesn't make sense. What's tricky in this problem is that there are 2 inequality symbols. So the simplest way to solve this problem is just to get the x by itself. So when I look at the part that has the x in it, I see x plus 2. So I can tell what I really need to do is subtract 2. Well, now it gets a little bit tricky. I'm subtracting 2 right there. Where else do I need to subtract 2? Well, I need to subtract 2 on the other side of both of the inequality symbols. So I need to subtract 2 from the 4, and I need to subtract 2 from the negative 1. Let's take a look at what we get once we've done that. Negative 1 minus 2 is negative 3. I have the symbol less than or equal to, x less than or equal to, and then 4 minus 2 is 2. So that actually is a statement of the solution. I can write that in right now. The solution is negative 3 is less than or equal to x, which is less than or equal to 2. What would that look like on the graph? Well, since x is between negative 3 and 2, I basically need to color in all the numbers in between negative 3 and 2. I can put a solid circle on the negative 3 because negative 3 will work. I have an equal sign. And I can put a solid circle above the 2 for the same reason. And all of the numbers in between those two will also work. So technically it's like I've put a dot on every conceivable number in between negative 3 and 2, including fractions, decimals, irrational numbers, everything. So it should be really easy to name 3 numbers in the solution set. I'm going to let you choose those, whichever ones you want. But I did want to show this problem in a slightly different way. Here's another way to think about the problem. There's actually 2 separate inequalities in here. Here's the first one. Negative 1 is less than or equal to x plus 2. The second one is x plus 2 is less than or equal to 4. And when they're written all together in one statement like that, it means we have the word and in between them. I didn't quite leave myself enough room to write that. If I solved the inequality on the left, I would need to subtract 2 just like we did in green, in the green work. That gives me negative 3 less than or equal to x. And now if I solve the inequality on the right, I'm going to do the same thing, subtract 2 from each side of the inequality, and that will give me x is less than or equal to 2. So I have negative 3 is less than or equal to x, and x is less than or equal to 2. Now remember, if negative 3 is less than x, that means the same thing as x is bigger than negative 3. So if I wanted to draw these two separately, x greater than or equal to negative 3 would have a solid circle on negative 3 and shade to the right. X less than or equal to 2 would have a solid circle on 2 and shade to the left. And now it looks a little bit more like what we did in the previous part of this lesson. Now we just take the overlap of those two. What are the numbers that are in both? Because we're combining with the word and you can see that it's the numbers between negative 3 and 2, and we get the same solution as we did when we solved it the first way, where I put the work in green. So I prefer that method. Rather than separating into 2 separate inequalities, I prefer just doing it all in one. And you can see that there are a couple of others like that one on this this part of the lesson. On page E, number 5 is similar to that, and on page F, number 10 is also similar. And then in practice 3.6, there may be a couple of other ones. So you're going to get more chances to practice that here coming up. Let me do just a few more, maybe 3, 4, and 5, and then I'll turn it over to you to finish the rest of page E and F and practice 3.6 as well. And that'll tell you how you're doing and if you're ready for the mastery quiz on this. Number 3, solve the first inequality. I would want to subtract 6. That would give me y greater than negative 7. To solve the second inequality, I would want to add 2. That's going to give me y is less than or equal to 6. Let's remember to put the word or in between there. So since I have these stated as 2 separate inequalities, let's do the usual technique. Let's draw 2 graphs high above the number line, and let's put the answer close to the number line. Y greater than negative 7 would have an open circle on negative 7 and shade to the right. Y less than or equal to 6 would have a solid circle on 6 and shade to the left. And then when I put them together with the word or, I don't need to leave anything out. I can put in everything that was in the first graph and everything that was in the second graph. And it seems pretty clear that since they overlap, I'm going to get the entire number line. So the solution set would be all real numbers. And it's certainly easy to name 3 numbers in the solution set. for that. Make sure you answer those parts before you turn this packet in. Number 4. I can see I have a number outside of the parentheses, and I can't subtract what's inside the parentheses, so I'm going to distribute. 2 times 5 is going to give me 10, and then 2 times negative x is going to give me negative 2x. So I have one place with an x. I need to get rid of the 10 and the negative 2. It makes sense to subtract the 10 first. That gives us negative 2x is greater than 2. And then divide by that negative 2 that's in front of the x. And I'll end up with x on the left. I need to remember to reverse the inequality because I've divided by a negative number. And then 2 divided by negative 2 gives me negative 1. For the other part of this compound inequality, I think we should subtract 4x and get all of the x's on the left side. That leaves numbers only on the right side. So we're almost there. We just need to get rid of that 3 by dividing it. And then we will have x is greater than 3. So let's put the word and back in between there. We need to draw the graph of x less than negative 1 and x greater than 3. X less than negative 1 will have an open circle above negative 1 and shade to the left. X is greater than 3 will have an open circle above 3 and shade to the right. Putting those together with the word and means I'm only going to take the overlap or the intersection of those two, and there is no overlap. So I'm going to put an empty set above the number line and an empty set next to the solution because there are no numbers that work. There are no numbers that are less than negative 1 and greater than 3. So as far as putting numbers in the solution set here, there aren't any numbers that work, so you can't write anything there. But don't leave it blank. Write something like none possible or no solutions. All right, let's finish up number 5 here, and then I'm going to let you see how you do on your own. You'll be able to check the answers with the answer document that is linked on the website. And that would be a really good idea when you finish, so that you can make sure you've done this correctly before you turn in this packet and say you're ready for the mastery quiz. This is another one of those ones that's really got 2 inequalities combined all into one statement. That means it has to be an and, it can't be an or. And the simplest way to solve it is just to get the x by itself, but whatever you do, do it to all 3 parts of this inequality. So I can see that x is multiplied by 2, and there's a 2 that's subtracted. So let's start by adding 2. And that will give us a negative 4 on the left is less than or equal to 2x, which is less than or equal to 2. Now we can divide everything by 2 to get the x by itself, and we'll have negative 2 is less than or equal to x, which is less than or equal to 1. So that is the solution. Negative 2 is less than or equal to x, which is less than or equal to 1. And x is in between negative 2 and 1. So on the number line, I need to color in between negative 2 and 1. I'm putting a solid circle on both because both of them has equal signs. Both of those 2 numbers will work if you plug them in. And that becomes the picture or the graph of the solution set. So now you have to name 3 numbers in the solution set. Now, a lot of you are going to be determined to name only nice numbers. Remember, you can also name fractions or decimals or irrational numbers as long as they're higher than negative 2 and lower than 1 or equal. All right, I'm going to let you finish the rest of this and then check your answers by looking at the answer document that's linked to this activity on the web page. Don't forget to finish number 6 here. The rest of this particular activity on page F, and you need to complete practice 3.6. So practice 3.6 is really just more problems exactly like the ones we have done. So when you get finished, check your answers with the answer document. Do your best, forget the rest. Bye for now.